So here's our Table G worksheet. I'm going to go over the highlighted problems and explain to you how to do them. They're not that bad. They just take a little bit of practice. So problem 1 says 60 grams of NH4Cl. That's important. We need to find that chemical on Table G. Is in 100 grams of water. This part is actually just referencing the amount of water that Table G is based off of at 90C. So I'm going to go to 60 grams and 90. So 90C, 60 grams, find the dot. Now, for the NH4Cl line, it's under the line. So therefore, this solution is unsaturated. If it was on the line, it would have to be like 72 or 73. That would make it saturated. And if it was above that amount, then it would be super saturated as long as I didn't change the temperature. Problem 2. At 20C, how much NaNO3 can dissolve in 100 grams of water? So what I do is I go to 20C. I find the NaNO3 line, which is this line up here. And now I'm just going to go all the way up and find where they meet. And then I'm going to go all the way over. And then I'm going to estimate what that is. So I would call that like 80, maybe 86 to 89 grams. Now, there's always going to be a range in your answers, but here's the issue. It's definitely not 85 because it's more than halfway up this grid box, right? And it's definitely not 90 because it's not hitting the 90 line. So 85 and 90 would be wrong, so I would accept 86 to 89. Number 3. At what temperature is NH3 and KClO3 equally soluble? So you find those two lines, KClO3 and NH3, and you find where they meet, which is right here in the middle, and then you just drop a line down and you figure out what temperature that is. I would call that maybe 56 to 58 degrees C. It's definitely not 55 because it's not quite in the middle, and it's not 60, so that's where my range came from. Five says, at 50C, a saturated solution of KNO3 contains how much more solute than a saturated solution of NH or NaCl? So 50C, NaCl, we find our point, it's right here. We draw a line over, and I get roughly, call it 38 grams for NaCl. And then I do the same thing for KNO3. So I go to 50, I go all the way up to KNO3, and then I draw a line over, and I get like maybe 84 grams. We'll actually do it this way. And we end up with, depending on the numbers you picked, you end up with like 46 grams, the difference. Now, obviously that can range because this number you could have called it 83 and this one you could have called it 37. So there's going to be a little bit of a range in the answer as far as acceptability, probably like within 2 grams in either direction, up or down, but that's totally fine. Okay. Number 8, 9, and 11. So 8 says, at 80C, how much NaNO3 can be dissolved in 50 grams of water? So here's the clue, or the issue. They're giving you 50 grams of water. Table G is based off of 100 grams of water. So what I'm going to do is I'm going to find my answer on Table G and then half it to make it into a 50 gram of water amount. So 80C, NaNO3, it's all the way up here. It ends up being like, what would you want to call that? 147. That's what I'm calling it. If you call it 148 or 146, that's fine. And then I just take that number and I half it, and I end up with 73.5. Again, depending on how you rounded this first answer, you could probably get something as low as like 72.5. I would definitely call it more than 145 because the halfway point's somewhere around there. So it's got to be over, what did that make it? 70, it's got to be 73 to probably like 74.5 roughly. So it's got to be somewhere in that. Somewhere in that range. Number 9, 110 grams of HCl is dissolved in 200 grams of water at 50 C. So this one is complicated because they're doing it in 200 grams of water, but here's the issue. It's already dissolved in 200 grams of water. So 110 was dissolved in the 200. I want to bring it down to my table so I can use it. So 110 dissolving in 200 is the same as if I dissolved 55 in 100. So that's why I'm going to go to 55 grams and 50 C. So that puts me here, and I have a point that's roughly right there. So now for the HCl line, I am under it by a smidge, and that makes it unsaturated again. Okay, so that's how you do that one. That one, this part wasn't hard, it was making the conversion down. And then the last one, 11, it says at 50 C, how much NH4Cl can be dissolved in 200 grams of water. So again, table G is 100 grams. They want me to do it into 200 grams. So now I'm going up to 200. So I'm going to get my answer and double it. So 50 C all the way up to NH4Cl. And I get roughly like 52 grams, something like that. And then, or 53 grams. And then I'm going to double it. And so I'll get anything in like the 104 to maybe even like 108 range, because obviously depending on it, your answer will be twice as off here because we're multiplying it by 2. So anything in that range is fine. And then the last one I wanted to do, which I did not do, was number 4. So let's do 4, and then that'll be the last one. So number 4 says you've got a supersaturated solution of KNO3. It's dissolved in 100 grams of water at 40 C. So I go to 100 grams, 40 C, put a dot. That's 110, so there's my dot. And then it's for the KNO3 line, which is all the way down to there. So then they say if a crystal of solute is added, that basically means they added a little extra, they disturbed it in some way. All the extra down to this line right here, or this point right here, is going to come out. So what you're going to do is you're going to find the difference between the 2 points and then just subtract, and then that's the amount that will crystallize out of solution. Another way of saying it is to say precipitate out of solution. It's the same idea. So in this case, it would be something like 35 to 38 grams that would come out depending on where you estimated this point here. So that's all the ones I'm going to go over. I am going to send out an answer key on remind, giving you the answers to the rest of the sheet so you could try them. There's also going to be a Castle Learning up on this where you get a lot of these types of problems using Table G.